this video, we are going to be talking about applications of exponential functions. So this first problem says, find the amount owed at the end of 7 years if $2,000 is loaned at a rate of 5% compounded quarterly. Use the formula A equals P times the quantity 1 plus R divided by N to the NT power, where A is the accrued or owed amount, P is the principal invested, R is the annual rate of interest, N is the number of times compounding periods per year, and T is the number of years. Alright, so we have 7 years, so we know T is 7 years. It says find the amount owed at the end if the loan was $2,000, so that's P, that's the principal amount of your loan. This should say invested or borrowed. At a rate of 5%, so the percent is always your rate. Our rate as a decimal, we 0.05, so change your percents to decimals. And N is the number of times compounded per year. So quarterly, that'd be 4 times per year. So N equals 4. And we want to know how much is owed at the end of those 7 years. So we're trying to figure out A is what's owed. So we don't know A. We know P is 2,000. 1 plus our rate as a decimal, 0.05, over N is the compounding, so 4 times per year, and to the NT power, N is 4, T is 7 years. So I would go ahead and simplify what's in your parentheses first. Let's clear this out. So 0.05, divide that by 4, and then add 1. We get 1.0125. 1.0125. Don't round that. Okay, we only round our final answer, so do not round that number. If it's a long number that's repeating, leave it in your calculator. Do not round it. And then I can do 4 times 7, so it would be to the 28th power. Alright, so now, again, leave whatever that number is in your calculator and take it to the 28th power. Again, we get this long, tedious number. Do not round it. We're going to take that answer and multiply it by 2,000. And now we round our final answer. So this is the final answer. It's money. So it's money. We're going to round it to the nearest cent. So 98, look to the right. And that's a 4, so the 8's going to stay the same. So 2,831 and 98 cents. 2,831 and 98 cents. And there you go. So my biggest thing here is identify each piece of the variables, what you know, plug it in, follow order of operations, so parentheses first, then their exponents, then the multiplication, and do not round until the end. So your final answer is the only thing that gets rounded. Go ahead and try this next example. Alright, this example says, as a result of a nuclear accident, radioactive debris was carried through the atmosphere. One immediate concern was the impact that the debris had on the milk supply. The percent Y of radioactive material in raw milk after T days is estimated by Y equals 100 times 2.7 to the negative 0.1 T. Estimate the expected percent of radioactive material in the milk after 5 days. So T is in days, and we want to know after 5 days. So T here is 5. And Y is the percent of radioactive material. So Y is what we're trying to find. So because we're estimating this, that's what we're trying to find. So Y equals 100 times 2.7 to the negative 1/10 times 5. There's nothing inside the parentheses to evaluate, so I'm going to go ahead and take negative 1/10 times 5 and get negative 5/10. Then take out our calculator, and we have 2.7, our exponent button, and 0.5, make it negative, equals, I'm going to leave this whole long thing in our calculator and multiply it by 100. So approximately 60.9%, or it doesn't tell us where to round it. We could round it to 61%. Again, the directions don't say, so we could say 60.9 or 61%, depending on where we want to round it. And there you go. The key to these types of problems is to identify what your variables mean, plug in what you know, and evaluate for what you don't know.